Previously, we have seen homogeneous systems and various aspects related to homogeneous systems. Now let's look at non-homogeneous systems. For a non-homogeneous system of linear equations, we use the concept of the augmented matrix. So let's say we have a system of equations. Remember, this is non-homogeneous because the constants are not zeros. Now, let's write the coefficient matrix and the constant matrix as A and B. Then the matrix which contains the coefficients and the constants differentiated is called an augmented matrix. The nature of solutions depends on the ranks of A and the augmented matrix. Remember, we can always evaluate the rank of a matrix, and ultimately this is also a matrix, so we can also evaluate the rank of this augmented matrix. If the rank of the coefficient matrix is not equal to the rank of the augmented matrix, then the systems of equations is inconsistent and therefore no solutions exist. If rank of A is equal to the rank of the augmented matrix, and let's say that is equal to R, then if R is equal to N, that is the rank is equal to the number of variables, then the system has a unique solution. If R is less than N, then the system has infinitely many solutions. Why? Because we will end up with some free variables. So now let's actually take an example and work through it. Let's say we have the system of equations x minus 7y plus 15z equal to minus 14, 2x plus 3y minus 4z equal to 6, 3x minus 4y plus 11z equal to minus 8, and 5x minus y plus 7z equal to minus 2. For a change, we have a system of 4 equations, but only 3 variables. The augmented matrix would be the coefficient matrix along with the constant matrix or along with the constants. Now we carry out the row operations, which brings us to this matrix. And if we carry out some additional row operations, we arrive at the reduced row echelon form. And here you will notice that the rank of A, that is this part of this matrix, reduced matrix, is equal to the rank of the augmented matrix, is equal to 2, which implies the rank, which is 2, is less than n, which is equal to 3. Remember, n is the number of variables. That implies that the system of equations is consistent. Now, using the reduced form, let's build the equations again. So we have x minus 7y plus 15z equal to minus 14. Y minus 2z is equal to 2. Now solving for y in the second equation, we get y equal to 2 plus 2z. Substituting it back into the first equation, we get x minus 7 times 2 plus 2z plus 15z equal to minus 14. Simplifying it, we get x equal to minus z. And minus z is a free variable, or rather z is a free variable. We can choose any value. So let z be equal to k. xyz is equal to minus k, comma 2 plus 2k, comma k is the general solution. And for k equal to 1, we would have xyz equal to minus 1, 4, and 1 as a particular solution. So by using different values for k, we can arrive at different solutions for this system of equations. And since K is in the set of complex numbers, there are infinitely many solutions. So that was non-homogeneous system. That's it for now.